Hello, I am 9 Team. Today I'm going to teach you how to create a quadratic equation if the original form is in factored form and how to convert it using the distribution method or FOIL into standard form. Depending on the form of a quadratic equation, it will tell you different things about the graph. For example, in factored form, we can see where a graph will cross the x-axis. In standard form, we can identify if a quadratic has a maximum or a minimum value. And we've been practicing creating quadratic equations and graphing them with scenarios. So for example, if you were to hit a golf ball from the ground, we would like to know how high that golf ball went in the air. Or if you were analyzing a scuba diver's path, you want to know how deep down in the ocean the scuba diver went, which would be a minimum. So I'm going to show you two different examples today. We're going to go backwards. The first example will be on the practice side of this mini lesson. And then the second example will be on the actual mini lesson page. So go ahead and make sure that you're on the right page. The first, you should be looking at the practice side of the mini lesson note guide. And let's go ahead and start with the very first graph. So we are given a quadratic graph. It's also known as a parabola. The parabola opens up towards the sky. So we will have a minimum value. Also, you can see where the graph will cross the x-axis. So let's start there. Let's start by going from left to right. So if you take a look at this graph, you can identify both x-intercepts. Here's an x-intercept. That's where our graph crosses the x-axis. And same thing here. Let's identify those points and write them in the x-intercept column. So the first x-intercept is located at, so I'm just going to kind of draw an arrow so you know where I'm going to write this down. The first x-intercept is located at -3, 0, and the second x-intercept is located at -7, 0. Okay, just to remember, when you have an x-intercept, the y value will be 0. Now, let's take our x-intercept and write them in factored form. Factored form is a way of writing a quadratic, although it's incorporating the x-intercepts. So I want you to take note briefly of the form, okay? And the form is written, the form of the equation is written right here underneath the title. So we are going to essentially fill in or write our factors inside of this form. Okay, so let's start by using our f of x label, then the equal sign. The a value, don't worry about the a value just yet. We're going to get into that in the next lesson or two. So the first thing that we have is a set of parentheses. I'm going to write this a little bit lower so I have some space. You start with your x, okay? Then you have a subtraction sign. That is what comes next in your format. R1 just stands for your first x-intercept. In our case, it is -3. So we're going to put in a -3. I put -3 in its own set of parentheses for a reason, and I'll show you why in a minute. Let's write the second half of this form. So you have parenthesis, x minus, because that's what the original, if you take a look here, that's the original form, and then -7. Well, the reason I have -3 and -7 in double parentheses is so then you can change those to a plus sign. Double negatives turn into an addition sign. So take note that sometimes, although your values were originally negative, they're now positive in factored form. Okay, I want you to take note of that the factored form looks a little bit different than the x-intercepts, but they're related. Let's go ahead and convert factored form to standard form. Okay, so now we're going to take our factors and we're going to turn them into an equation that looks like that. Let's go ahead and start with your two factors, okay, from factored form. Now, we need to make this look like the form above it. To do that, we're going to use FOIL, the FOIL distribution method. Or I've been teaching my class to distribute the factors one at a time. Either way, it's the same process. So if you take the first term, which is x, and you want to multiply it by the second two terms, here and here. So x times x is x squared. X times 7 is a 7x, a positive 7x. Now you will use the second factor to multiply by the other set of factors. So we'll take our 3 and multiply by x and 7. 3 times x is a positive 3x, and 3 times 7 is 21. Now, a way to to verify that you did this correct, you should be able to add your middle two terms together. They should have the exact same variable and the same power. So if you look here, we did this correctly because you can add your two terms in the middle together. Your final answer ends up being x squared plus 10x, because you can combine those, plus 21. You have just converted factored form to standard form by using your x-intercepts. So they're all directly related. They just tell you different things about your graph. Let's analyze those a little bit closer. So flip your paper over, and then let's work with the first example. So we have a parabola that opens up again. They gave us the factored form, okay? Keep in mind, the factored form is related to your x-intercepts. So if we take a look, let's just pinpoint those. Here's an x-intercept, and here's an x-intercept, okay? They went from factored form to standard form by distributing this to distributing factored form to create your standard form. And now let's write our x-intercepts. So if you're not sure how to identify those from factored form, take a look at your graph. The first one is located at -2, 0, and the next one is located at 4, 0. What do you notice between this one and this one? Just take note and go ahead and answer what you notice about those two right here under question 1. Question 2. Let's say you weren't able to identify your x-intercepts using your graph. So all you have available is your factored form, okay? So you have x plus 2, and you have an x minus a 4. How could I get my zeros, or my x-intercepts, they're also known as, from this factored form? To do that, you can set each of these factors equal to 0 and solve. So let's go ahead and use the first factor, set it equal to 0, and solve it. To solve for x, we would subtract 2. Okay. Our positive 2 and our negative 2 would cancel. So x would be equal to -2. Take a look. It directly relates. So there is a way to kind of flip-flop back and forth, so you can use your x-intercepts to write factored form and vice versa, and then convert all of it to standard form. Next class, we will be able to go from standard form to factored form using a factoring method. Please finish the rest of this worksheet as homework. Thank you.